Okay, so I mentioned there are three different ways that you can solve simultaneous equations. Okay, simultaneous equations basically being when we've got two equations with two variables each in them. The first one was graphically, so drawing a graph and find out where they intersect. The second one is substitution. Okay, so you've already actually done a lot of substitution by taking a number and substituting it into an expression and then working it through. This is slightly different, but works in much the same way. Substitution doesn't change. We're still going to take something and replace it by something else. That still stays the same. It's just going to be slightly more complicated. It's basically just going to involve those two equations. Okay, it's not necessarily the method you're going to use most often going forward with simultaneous equations, but it is a very important aspect of maths, and going forwards is important to know nonetheless. Okay, but a lot of the three methods, the choice of which one you take is based on the form that you're given the equations in. So after a bit of practice, you'll kind of see that the different forms lend themselves perhaps to the different methods. Not necessarily graphically. Graphically is always going to be a bit of a faff. But the other two, depending on the equations and the way that they're written in the first instance, one might be better than the other. Okay, and we'll go over that once we've gone through all three different methods. So the choice is generally yours. You can pick graphically if you really fancy doing it graphically. Generally, you're not kind of limited to one version. They might say, as in the last questions, they might say solve this by graphically, or solve this graphically, solve this by substitution. They might tell you which one they want to see. However, if it just says solve, you've got that choice. Okay. As I said already, this one though is substitution, and you've done substitution before, but in a slightly easier context by basically taking out a letter and replacing it with a number. What we're going to do here is slightly different. We're going to do the same first process. We're still going to take out a letter, but what we're going to do is replace it with, rather than a letter or a number, we're going to replace it with an expression. So something that's basically made up of letters and numbers. Okay, and once we've done that, then we should be able to solve it through. But I'll take you through this first one in a lot more detail and then give you kind of a couple more examples thereafter. So we've got these two equations. So similar to the last one, similar to when we're doing graphically, but the format, this is written in a slightly different way. And the way that this is written, because it is y equals, lends itself quite nicely to this method. They're not always going to be written like this. The ones that we had when I was looking at graphically basically had the letters on one side and just the number, so the +4 or the -2 here, left on the other side. If that's the case, then you might want to take a different approach. Okay, but because this is y equals and y equals, it lends itself quite nicely to substitution, and you'll see that hopefully going through this. So first of all, note that they're both y equals. Right, if we knew that y was equal to 10, so if in the question, if you remember back to it earlier, you were told perhaps a is 3, b is 4, c is 2, simplify these expressions. All you do is you basically take those numbers, replace their letters with those numbers, and then you work it through. And likewise here, if we knew that y was 10, okay, we could take either one of these equations and we could substitute 10 into it, like so. So all you do, if you knew that y was equal to 10, you take the y out, and then you put the 10 in its place. Now all of a sudden you've got an expression or an equation, that you can solve, as it was previously. So when it was y equals 3x plus 4, you can't solve that. As we discussed, there's infinite solutions to that. But now that I've replaced one of the letters with just a number, there's only going to be one solution to this. And it just comes about by solving equations just as normal. What you're trying to do is you're trying to get x equals something, in which case you move all the numbers to one side, move all the letters to the other side, and then you solve it. Okay, so here, first thing we do is we take away 4 from both sides, and we'd get 10 minus 4 is 6. Take away 4 from this side, we get 3x. And if 3x equals 6, don't worry about the fact that it's written this way around. If 3x equals 6, divide both sides by 3, and we get x equal to 2. Okay, however, that's not the question. That's just showing you what substitution means in the kind of the methods that we already know. Okay. So for this question, what we've got is we know two different versions of y. We know that y is equal to 3x plus 4, and we know that y is equal to 5x minus 2. So rather than substituting the y for 10 as we did in this first example, what we're going to do is we're going to substitute the y for one of the other expressions. Okay, so if I go back to that first one, we've got y equals 3x plus 4. I know that in the other expression that y is also equal to 5x minus 2. Right, I couldn't just go 3x plus 4 equals 3x plus 4. Okay, that's all that's going to happen there when we work it through is I'm just going to end up with nothing. I need them to be different. I need the two sides to be different. So if I start with y equals 3x plus 4, I then have to use the other equation. And I also know that y is equal to 5x minus 2. So much in the same way that I did the previous one. Took out my y, put in the 10 instead. Here I'm going to take out the y, and I'm going to put the 5x minus 2 instead. And now I've just got an equation, okay, that again has only got one letter, so I can solve it, and there'll only be one solution. But I've just got to remember how I solve equations. Remember to get all the x's to one side, all the numbers to the other side, and just work it through. So here, first of all, I'd add 2 to both sides. So 5x equals 3x plus 6. Take away 3x from both sides, 2x is equal to 6, and then x is equal to 3, okay? This is where a lot of people would stop. They think they've solved it. They've done some equations, they've done some maths, brilliant, okay, absolutely done. But you're only part of the way here, right? The idea of these questions is we find out what x is and we find out what y is. Okay, so you're only halfway there at this stage. Once we know what x is, okay, then it's easy to find out y, because we know that y is equal to 3 of our x's plus 4, and we know that y is equal to 5 of x's minus 2. So we can substitute x is equal to 3 into either one of those equations. Okay, so I've picked the first one, y is equal to 3 of my x's plus 4. Now that I know that x is 3, it's 3 times by 3, and then add on 4. 3 times by 3 is 9, add on 4 is 13. I could have done that with the second one, okay, and it would have worked exactly the same way, and it's a good way to check that you've done the first bit correctly. So if I substitute x in this one for my 3, I would have got 5 times by 3, which is 15, and then take away 2 is also 13. If they don't match up, if you do it in both equations and they don't give you the same answer, then you've probably done something wrong in the first instance. But you can see here, no matter which one I substitute x for 3, I still get the same value of y. And that means that my answer is that x is equal to 3 and that y is equal to 13. So there's two answers here, or two parts to my answer. X is equal to 3 and y is equal to 13. And they're the only two values of x and y that solve, in other words, satisfy, or solutions to both of those equations at the same time. Okay? And that's the process that you basically want to do when you're using substitution. However, as I'll show you from these two examples, it's not always as straightforward as that one. The first one's pretty straightforward, but the second one is a bit more complicated. So let's start with this first one. So the letters are usually x and y, but sometimes we get a and b, sometimes we get different letters. Okay, it doesn't really matter. You're still going to do it in the same way. Basically, what you want to do is you want to take something out of one of the equations and substitute in the other equation. As long as that's the case, then we should just be left with one variable. And as long as we've got one variable in our equation, we can solve it. Either of these individually, I can't solve. Okay, I can't solve to give me one solution, but if I combine them both together, if I do them at the same time, if I do them simultaneously, then I can solve it. So all I'm going to do here is I'm going to take this equation and substitute into the other one. And you can see what happens here is basically the b's come out and then we make the two other sides equal to each other. 8a minus 3 is equal to minus 2a plus 7. Now I have one single equation with one single variable. I've just got to gather them all together and solve it as I normally would. Okay, so if I add 3 to both sides, be very careful with your negatives. Okay, add 3 to this side, I'm left with 8a. Add 3 to this side, I've still got my minus 2a, and I've got a 10 now. So I'm going to move the 2a over, in which case I'm going to add 2a to both sides, and then I get 10a is equal to 10. And all I need to do here is divide by 10, in which case a is equal to 1. Just remember, when you get to this stage, you're not done. You found out what a is, but the whole point of the question is to find out what a is and what b is. So all I need to do is pick one of these, and it doesn't matter which one. And I'm going to substitute a for 1. So I'm going to pick that first one because I don't like the negative here. 8 times by 1 is 8, and if I take away 3, I get 5. Okay, if I'd chosen the other one, if I substituted a for 1 here, I would have got minus 2 times by 1, which is minus 2, add on 7, I still get 5. So that is a good way of double checking that your answer is correct, because as I say, if they don't match up, if you don't get the same b in both of them, then you've probably done something wrong here. So it's a good way to check it and make sure we get both of them and just make your answer nice and clear. Okay, it'll be important further down the line to make sure your answer is nice and clear. So start getting used to that now. A is equal to 1 and b is equal to 5. And again, that's the only solution that satisfies both of those equations. If we were to draw these, and we could just do we could do these graphically. Obviously, it's not x and y, but we could have an a and a b axis. Okay, we do exactly this. We find exactly the same thing. We draw these graphs. Okay, and we find that the point of intersection would be something like 1, 5. Okay, so it would still give us the same answer. It doesn't matter, but obviously we're doing it this way. We don't have to draw any graphs. It's a little bit quicker. Right, for the second example, okay, and you've got to be aware of a few things here. This is difficult in a number of ways, but the first thing to be aware of is that they're not both in the same form. Right, there's going to be any number of different forms that you could be given these equations in. Okay, and you've got to adjust your working to those different forms. So here I made 8a minus 3 equal to minus 2a plus 7 without really even thinking. I can't do that here because they're not both m equals or p equals. One of them's m equals and one of them's p equals. So I've got a different kind of route to take here. But what I can do, I'm still going to substitute. I'm still going to replace my p, okay, with this, or I could replace the m here with all of this. Okay, either way works absolutely fine. And you'll see what I've done here. Okay, all I've done is I've basically substituted this p for a 3m minus 4. Just got to remember that it's 2 times by p when p is 3m minus 4. So it's 2 times by all of that, which is why I put it in brackets, and then I would add on 5. So I'm still substituting. I'm just not substituting at the start of the equation. So m is equal to 2 of my p's, and I know p is equal to 3m minus 4. So it's 2 times by 3m minus 4 plus 5. I've still got the same outcome. I've still got one equation. Okay, so one line with an equal sign with just one letter now. Okay, here I had 2 letters. That doesn't help me. I can't really find a solution here. I want to combine them both, so I'm just left with one letter. And that's what substitution does. It takes out a letter that I don't want, replaces it with something that I do want. Now again, it's just solving, but it's just solving a slightly different equation this time. So get rid of the brackets first of all. Remember to multiply everything through by 2, so it would be 2 times by 3m is 6m, 2 times by minus 4 is minus 8, and then it's just a case of simplifying. Minus 8 add 5, it gives me minus 3. Move all the m's to one side, and I get minus 5m equal to minus 3. And you can see this is not going to work out very nicely, but that doesn't mean we're wrong. Minus 5m equals minus 3. I have to divide both sides by minus 5, in which case I get m equal to minus 3 over minus 5, which simplifies to just 3 over 5. Okay, that wasn't so difficult at that stage. Yes, there was a bit of fractions involved. Yes, it was a bit tricky at the end. But the thing is, now I have to use this. I'm not done. Okay, I still need to find out what p is, and to find out what p is, I have to use my m value. So you need to know your fractions here. But you'll have these different examples. You big kids now, we're working through this. We'll get all these different things in terms of maths that we've looked at before. Okay, fractions, you might get powers, things like that, all come up. You have to be ready to deal with them. Okay, but same idea as before. Here I took my a and substituted into one of them. Here I'm going to take my m and substitute into one of them. I could use this first one, but I like the look of this one. P is equal to 3 times whatever my m is minus 4. So I'm going to use that one. So it just everything's on the one side, and I can just solve it all together. All right, 3 times by 3/5. That's what I'm doing here. 3 times by m. M is 3/5, so I'm going to do 3 times by 3/5. Right, when you are multiplying like this, you just times the top. Think of the 3 as 3 over 1. So it's 3 times by 3 over 1 times by 5. Either way, it's 9/5. And then because I'm going to be taking away, okay, I need this. If I'm taking away fractions, I need the 2 things that I'm taking away to have a common denominator. So I'm basically going to change my 4 into fifths. So 4 is the same as 20/5. So I've got 9/5 from here minus 20/5. 20/5 is just a 4, but now I've got it in a situation where I can actually take them away. 9/5 minus 20/5 is minus 11/5. And although that's not pretty, it is the answer, and I could put it back into the first one to double check. Make sure you write your answer nice and clear. M is equal to 3/5 and P is equal to minus 11/5. Okay, so that's simultaneous equations by substitution. Okay, so you've got graphically, you've got substitution. There's one more to come. This one is a little bit easier, obviously, than graphically in terms of the fact that you don't have to do as much work, and is a very useful one going forward. But the third method is probably going to be the most prominent one, the one that we use most often. Okay, but give this a practice first.